All right, so now we're going to focus a little bit more on the zeros of polynomials. Obviously, when a function is factored, it is easy to find the zeros, right? So here we have f of x equals x plus 5 to the third times x plus 1 squared times x minus 4. And we can answer a couple of things about this, right? First off, first question is, well, what's the degree? And we're not going to multiply this out, okay? Do not multiply this out. Let's write that over here. Do not multiply out. Okay, but what we will do is like a little mental exercise and say, okay, if I did multiply out x plus 5 to the third, what's the highest power term I would get? Well, I would get an x to the third. If I did multiply out x plus 1 squared, what's the highest power x I would get, along with any coefficient attached, right? I would get x squared. And if obviously x minus 4 is just x, so if I multiply x to the third times x to the second times x, I'm going to get a highest power of x to the sixth. Every one of those just has a coefficient of 1, so this is our leading term, which means our degree is 6. Okay, so, sorry. So what are the zeros? What's the multiplicity of each? Well, we're going to say, okay, take each factor, set it equal to 0. So that's going to get us x equals -5. And that is repeated however many times that factor is repeated. Multiplicity 3. So I'll write up here, multiplicity of a 0 is the number of times that factor is, say, present in the polynomial. Okay, so what's our next factor? We've got an x plus 1 squared, but it really just is the x plus 1. So that means one of our zeros is -5, and that has a multiplicity of 2. And then we have x minus 4 equals 0, so our 0 is x equals 4. That one has multiplicity, which is a really long word to write out, of 1. So there's our zeros and the multiplicity of each. So we have 3 zeros, but we know from a degree 6 that it has a max. Degree 6 has a max of 6 zeros and 5 turning points, right? And obviously this one has less because these zeros are repeated. And so we want to do a little exploration of exactly what happens with those repeated roots. So what we do know on this one is even powered, right? So we're just gonna say yes for now, and that's going to come up in the next video, or the next slide rather. But we do know our long run behavior here, right? Our leading term is x to the 6th. So both ends are going to be going up, right? And we know we have zeros at -5, -1, and 4. So somehow we have to go through those zeros and still end up going in the right direction. So we can kind of say, well, let's kind of make a guess. See, like we know that's not going to work because I can't get back up to the headed up side. So at least one of these has to not actually cross the 0. Okay, see, like that would work. Okay, so we're going to go on to the next one here. And actually, you know what? I'm going to break the video here because we're at 4 minutes. And this is going to take a little bit longer. I don't want to make this video too long.